Good morning, everybody, or afternoon, recognizing that it is afternoon in some places. I personally am in Calgary, so not afternoon for me quite yet. Welcome to another edition of Discovery. My name is Alison Mostowich. I am the Director of Engagement at Efficiency Canada. I am joining you from Calgary, as I mentioned, home of the Blackfoot Confederacy, the Tsuut'ina, the Stoney Nakoda Nations, and the Métis Nation Region 3, as well as the people who make their homes in the Treaty 7 region of Alberta. So while we're a remote workplace, Efficiency Canada is actually based at Carleton University, which is located on the traditional unceded territories of the Algonquin Nation. So I think many of you know this, but before we get started, just a reminder that we'll take about 20 minutes to do the presentation, and then we'll have some time for questions after. Please remember to use the Q&A box at the bottom of the screen. So you should be able to type your questions in there. You can also upvote questions. So if you hit the like button, the more likes a question gets, the more probability there will be that I get to that question. You can popularize a question if you like. You can also use the chat. If you have some comments, I'll try to get to the comments in the chat, or if you have any questions, don't put questions in the chat. I'm going to stop myself before I even say that. Put the questions in the question box and any comments in the chat, and I can certainly read those out. So today I am very pleased to introduce Surya Narcia, who is the Senior Director of Innovation with Summerhill. And he's going to talk to us about a tool that Summerhill developed to make everyone's lives easier when they're doing home evaluations and blower door tests. So Surya, with that, I will hand it over to you.
All right. Thank you very much, Alison. Hello, everyone. Good morning or good afternoon again. I'm also joining from Calgary, actually. And thank you for tuning in. And thank you, Efficiency Canada, for giving us this opportunity. We are very happy to share our experiences and lessons learned from several air sealing pilot projects across the country. And as we go through a quick overview of the agenda, we'll talk about Summerhill, who we are quickly, and our experience in air sealing, some key takeaways and lessons learned, and how we address some barriers to a standalone residential performance-based air sealing program, and introducing our calculator for that, which actually addressed some of those major barriers. Summerhill, so we would be proudly celebrating our 30th year, actually 30th anniversary this year, founded in 1993. We are a 100% Canadian owned and operated energy services company. We are involved in program design and implementation with our utility and government clients from coast to coast. We actually currently have presence in 9 provinces and 3 territories across the country. We deliver a full suite of program implementation services for commercial and residential sectors, which could range from direct install programs to commercial and residential energy audits through contact center, and we also do incentive disbursement. So jumping on to air sealing pilots, so we'll introduce what we have done so far. Over the past few years, essentially from 2021 to late 2022, we have been exploring air sealing as a standalone measure and the approaches through which we could deliver this through the rebate programs. And as you would have seen, most of the time, air sealing is offered as part of other incentive, but we have been exploring that as a standalone one. And so we have conducted 2 residential air sealing pilots and 1 commercial over the past 2 years. So the first one was with Enbridge, where we recruited 97 homes in the GTA. And this one, we tested a performance-based air sealing program using blower door testing. So the idea here was to compensate the contractor for the amount of air sealing work that they have done. So the more tightening they got the house to, the more we provided the incentive amount. And this is where the calculator was developed to assist into and make assessment of the energy savings. And we are going to talk about the calculator a little bit further in the presentation. The second pilot was with the City of Vancouver, where we recruited 24 homes. And this particular objective was to test 3 different measure types, essentially aero barrier, spray foam, and basic air sealing. And each of those 24 homes got one of those measures. And the way we evaluated the savings for that one was to conduct a full Energuide audit before and after the air sealing work was conducted. The third pilot is on commercial buildings. This one was a project that was co-funded by Efficiency Manitoba and STDC, Sustainable Technology Development Canada, where we tested 10 buildings. And the process over there involved infrared thermography. So we had the cameras mounted on drones that flew over the buildings, took thousands of pictures, And then those pictures were analyzed. We could identify the locations of the leaks and also quantify the losses through that. I'm just listing out the different sponsors for the different programs, for which we are very grateful for those for giving us the opportunity there. So what were the key takeaways and the lessons learned from those programs? On the residential side, first observation was the aero barrier process is quite financially demanding. It's about 2.5 times when you compare that with basic air sealing or even spray foam. Spray foam or basic air sealing was averaging around $3,500 per house, while the aero barrier was about $8,500 per house. But that said, the amount of reduction in air changes per hour was quite significant with aero barrier. We were looking at about 57% on average, compared to a maximum of 13% with spray foam or basic air sealing. Now that said, obviously it might look like, okay, one measure is better than the other one, but essentially what happens is depending on the house, depending on the condition, it may be the house may be suitable for just basic air sealing. Not every house needs an aero barrier measure. Similarly, not every house needs a spray foam. So the assessment has to be done for a case-to-case basis. But comparing these three measures on the long run, it appears that aero barrier could be a more cost-effective if we would factor GHG emissions and the cost of carbon and all that. The other observations were that penetrations were the most popular measure. So as you can see in this graphic here, leaks are always happening in the house. There are always gaps when the roof is joining the top concrete floor or at the basement, or penetrations like these where pipes are entering the building, or a conduit for electrical panels, flue gases, piping and all that. There's a lot of penetrations, and we observed that penetrations were the most popular thing. So this could give some idea how we want to tackle air sealing as we process. Another interesting observations was that the houses that were built in the 1990s and later appear to have the most savings potential. That seems to be quite counterintuitive when we think that older houses would be more leaky. So one explanation for that could be that these older houses would have probably, like a house older than 30 years would have already done some retrofits. Maybe they have changed the roof already and windows and other renovations. So in that process would have fixed most of the leaks. So that's one explanation for that. On the commercial side, we observed that infiltration losses through buildings could range between 5 to 17% of the total building envelope losses. And interestingly here, the observation that we had was most of the leaks, about 67%, are happening around window frames for a commercial building. This obviously is dependent. It's a data set of 10 buildings, but something interesting to keep in mind if you are running more and more pilots like these or scanning more buildings. And about 20% leaks are happening through the roofs. So just these two itself would make about 87%. So if we want to consider an air sealing program for commercial, probably this is indicating that the biggest bang for the buck is probably looking at the roofs and the windows as a starting point. We had some significant learnings as well from these projects. One of the main observations was contractor recruitment is a big issue. There is no actual or hardly any contractor that is specialized in air sealing work in the market. Most of the time we have to go through either getting renovation contractors or maybe insulation contractors. So that's difficult to find. The other challenge was scheduling. As I mentioned, for the City of Vancouver pilot, we had to hire EAs, energy advisors, to conduct a full Energuide audit before and after, plus booking an appointment for the air sealing work. So that's 3 appointments. And when you have a short period of time, it becomes challenging to get the homeowners to be available for 3 times in a short period of time. Project cost was a big challenge. Where cost of material went up, cost of labor went up. We actually had to seek for other additional budgets, and thanks a lot to our co-sponsors for those projects. One of the major challenges also is the disruption from requiring homeowners to vacate their homes. So that applies for the measure of aero barrier. This is a measure where they have to spray the product inside the house. So the process involves removing the furniture, masking the remaining appliances in the house, covering the countertops and all that. and then the homeowners have to vacate their home for about 4 to 5 days. And this is a big disruption. It could be, in some cases, the cost also went up for those, as you could imagine, the difference you saw earlier. Another important point in lessons learned was that the minimum air change requirement is an important one for safety. We had to keep this for 3.5 if the house didn't have mechanical ventilation. And we could have done more air sealing if the house has mechanical ventilation. How did we address some of the barriers that we saw? The main one here was, you could imagine the time and the cost that is involved in conducting a full Energuide audit before and after air sealing work is done. So if we're looking at deploying a standalone measure for air sealing and using Energuide audits, it becomes difficult, challenging, costly, time-consuming, prohibitive in some cases. So we have tried to solve this problem by building this calculator, which is essentially targeting only energy losses through natural ventilation. And this calculator uses blower door testing and a few local parameters from the site. We have put it in an app so that the contractor, when they go on site, it's easy and can use that right away. So let's explain how the calculator works. Firstly, introducing what is infiltration. How does infiltration happen in a house? The first cause of infiltration is temperature difference. As you can see in this graphic, let's say it's a winter situation where you're heating the air inside the house. So hot air will tend to rise. And if there are gaps in the house at the bottom, cold air will enter in because hot air density is lighter, so it goes up, cold air enters the house and then drops the temperature, comfort issues, and so on and so forth. This movement creates a pressure difference between inside and outside the house, and that is how air flows in and out. The other cause of air leaks is through the wind. So as wind is blowing over the house and hitting corners and different sections of the building, it creates zones of low pressure and high pressure. And this, again, creates another difference of pressure between inside and outside the house. Because of that, if there are gaps, leaks occur. And as air is flowing over the house, it creates some swirls, and this is what actually creates the low pressure. In fact, you can see the pattern of the swirls. If you look at snow after some time on the building, on the roof, you could notice the swirls. And if there are gaps in those corners, air is going to leak into the house. So in the calculator, we essentially look at calculating both the stack factor, which is due to temperature, and then the wind factor due to the wind. So the first set of data that we have in there is the weather data. It is built in the calculator for the region. It is hourly data of temperature, wind speed, dew point temperature, humidity, and all that. And we use this to calculate the stack factor and the wind factor. We also collect other site data. For example, the type of house is important. I was talking about stack factor. So the taller the house, the more the effect of this. So a house like this, which is a 2-story single family detached, would have a different stack factor as a one like this, which is a 1.5 story, or even the bungalow style, which is 1 or 2 split levels. So stack factors will vary. So the app has a 6 group of selection available as a drop-down menu, and the contractor can select and proceed with the calculation. The reason we have this is that it could be sensitive to the calculation here. Choosing one house against another could impact the result by about 6%. The other side data we collect is about shielding. So what we mean by here is if you look at a house like this in an open field, maybe just trees around, and compared to another house in this condition where it's more crowded, the impact of the wind on the house is going to be different in those cases. It's important to select the proper site situation in those cases. So in this particular aspect, we have 5 categories of shielding, and by visual observation, the contractor on site could decide which one to pick. It's important to be accurate in this as the results could be impacted by about 5% if you look at the final savings. And the last parameter that we need to collect from the site is about the terrain condition. So we have 8 categories. We have situations where the house could be on a plain, there's no obstructions around. So the wind effect would be very different as compared to another building which is surrounded by trees. Or if a building is close to the beach, that's a different kind of wind effect as well. And then we have buildings within the city, tall buildings around them causing impact on the wind. So all of that is very important, and we need to capture these from visual observations. This could impact the results if we make the wrong selection by about 7.5%. We did a comparison of the major parameters of the calculator with HOT 2000. So the two major parameters are, one is the leakage characteristics. So those who know HOT 2000 will know about the flow exponent and the flow coefficient. Our calculator matches HOT 2000 to 100%. And the other variable that is used is the equivalent leakage area at 10 pascals. And for that one, we were accurate as close as 99.75% with HOT 2000. So we'll run a quick demo here. This is the app. This is how it works. So we have a first page where we are collecting basic information of the site, the weather data. The contractor will take some measurements of temperature, wind speed, and other like eaves heights that are needed for the calculation. So as you can see here, the drop-down menus are showing up, or will show up in a few seconds, where it's easy for the contractor to just select a drop-down menu. And this is all factored in the calculations. And then we run the first blower door test, where it's a multiple point blower door test. We would collect pressure, differential pressure, and CFM for interval of 5 pascals between 25 to 50, and then populate into the calculator. Once this is done, then the contractor goes and finish all the air sealing work, and then come back and run another blower door test, a 5-point or 6-point test, and record the data again in the next page of the calculator. And as the data is entered, just take a few seconds. So that's literally the speed of how the calculator works. And once the data is entered, we get results right away, as we are going to see right now. So this is a 6-point test. As you can see, the potential incentive in that case was about $1,800. So this is how the contractor immediately knows, before leaving the site, he or she knows exactly what is the incentive amount. And we have customer surveys where we collect customer satisfaction right away. It goes into our system and that is recorded. So this is essentially what the calculator is doing. It's calculating only energy loss infiltration at natural pressure. User-friendly, it's fast and efficient, as you saw. It's ready to go. We have a few other steps to move on for fine-tuning that. And to conclude, essentially, to be able to run a standalone air sealing program, especially a performance-based air sealing program, it's important to have the best balance of incentives, training for contractors, especially finding specialized contractors in air sealing, and educating the consumer, making them more aware. These three combined, we definitely can increase the uptake of air sealing for homes and even commercial. What are we looking at next steps? So this app is ready to go. It can be customized to the different geography around the country. And we are working with our various pilot partners to explore the next steps beyond the pilots. Full-scale rollout opportunities are there, and then further testing, probably get more data and fine-tune the model. And for phase 2 of commercial air sealing, we are working on finalizing some analysis right now and see how we are going to use the information to inform a commercial air sealing program. So again, another standalone air sealing program for commercial buildings, which is technically not much existing in the market right now. So that's all I have for today. Thank you very much for your time. Really appreciate your presence today and would be happy to answer any questions.
Awesome. Thanks so much, Surya. That was fantastic. So we do have some questions in the chat and quite a few questions about the aero barrier. And I guess maybe some that kind of connect back to some things on the larger scale I'm curious about. First of all, I'm curious to know the aero barrier measure, how much of the measures that you were using in the pilot were covered by different incentive programs or potentially greener homes specifically? Is there any financial incentive to choose one measure over the other?
As far as I know right now, it doesn't really matter. I think for the greener homes, not too sure how the program works, but I believe it is building the business case to make and show this potential savings and get the incentives from there. But in the pilots, we didn't use any incentive as such. These were all funded by the different partners to test the technology. But essentially, we wanted to find out how the savings compare with others, the cost and the practicability of the measure, especially getting the right contractors on site and the other challenges as we saw. So that was the idea, but definitely something to consider looking forward, how greener homes could probably have different incentives for different types of air sealing measures.
Okay, great. So just continuing along with aero barrier, Joseph had a question about the longevity of the aero barrier measures. The longevity of those, or really any air sealing, like how many years would that improvement last for?
Usually based on industry standards and what has been also published in a lot of technical manuals, the lifetime of air sealing measure is typically 15 years. That's what they claim to have. And I think it's safe enough when utilities are doing their calculations of lifetime GHG equivalent savings and doing the metrics for incentives. 15 years is typically what is being used for this measure.
Okay, interesting. That's decent for a payback period too, because I know I harassed you with that question many times when we were working together.
Yeah, that's what I think. You can see that it's upfront very expensive, but if you look at over 15 years, it's a different financial scenario.
Yeah, especially with the cost of electricity the way it is right now.
Correct.
Okay, Pierre wants to know, what is the proportion of energy loss in residential building caused by infiltration?
What we have observed is also between 10 to 15%, but in some rare cases, we have seen 30, 40%. That could be in very leaky homes. And based on the data set that we had from the first pilot with Enbridge, we have had situations where ACH reduction has been in the range of 60 to 70% in some very old houses. And typically, sealing as a percentage of loss from the building envelope is about 15% on average.
Okay.
We had better visibility in the case of the commercial pilot where we use infrared. That showed us again the same range it can be anywhere from 5 to 17%. So for a house, it will be almost about the same as well.
Okay. And this might be a bit too specific, but there's a question about the proportion of filtration due to extractor fans. Did you get any data on that?
So this is actually taken care in HOT 2000, where extractor fans would be, if it is not running, obviously it is going to be natural infiltration, but if it is running, depending on the length of time, that could be significant. So if you have an extractor fan that's running 24 hours in a house, the air leaks to that will be significant, and we can model that, definitely. In this model, we didn't consider mechanical ventilation and extractor fans as part of that, but it can be definitely modeled. And we do have that. Like if somebody is using HOT 2000 for that, we can see the extent. The HOT 2000 uses about 5 or 6 hours of runtime of extractor fans in the model. So if you change that, we could see the impact.
Okay, thank you. So the next question is about clean air. So how do you secure clean, fresh air circulation in sealed interiors?
Mechanical ventilation. Something which is very common in the market now. All new homes are being equipped by HRVs, heat recovery ventilators, or energy recovery ventilators. So this is mounted in or just around the furnace in the house, where it takes in fresh air from outside, and that fresh air gets pre-cooled or preheated with the exhaust from the house. And then, so you have fresh air with oxygen, 20% going inside the house and feeding this. It's actually a building code. If you're tightening the house below 3.5 ACH, you need mechanical ventilation, something like an ERV or HRV.
I believe you. I'm not a technical person, so that sounded that sounded right.
Sounds right.
I know you're right. Okay, so a couple questions about, hopefully you know what this is. I don't. H2K. So we have a couple people just noting that they're seeing some similarities with the H2K tool. And just wondering how this product differs, how the app you've built and the calculator you've built is different or is better than H2K.
Yeah, that's a good question. And I didn't mention that before because I was waiting for the question, in fact. So H2K is HOT 2000. So it's abbreviated H2K. The calculator actually is using this exactly the same principle that is used in HOT 2000. This is based on the Alberta air infiltration method. It's the same formula. It's the same thing which is used in HOT 2000. So this is essentially an extraction of HOT 2000, but only for air sealing, natural ventilation. And that's why we see there are similarities. We tested against this industry accepted tool so that we know we are on the right track. It uses the same technique, same formula that is used in HOT 2000.
Okay, I should have known that. Okay, thank you. This is a really good question. Has Enercan shown any interest in potentially using this technology for their energy advisors for the Greener Homes program?
This process is on our list to approach them and have this conversation to see what procedures and process for them to validate the tool and then take it to market. So that's definitely on our bucket list for next steps.
Yeah, that would be amazing. I know that Enercan's actually quietly doing a review of Greener Homes right now. I would just encourage anybody that's on the call right now to, if you do have feedback and So many of us do have feedback about greener homes. Now would be a really good time to send it to Enercan. They are doing sort of a quiet review of the Greener Homes program. Okay, so another question about mechanical ventilation. So what scope is there for adding mechanical ventilation to remove the minimum air change limit in older homes without air exchangers?
Well, the house needs to breathe, which is basic thing about that. So other alternative without mechanical ventilation is to obviously make sure the house has an air changes per hour, which is not less than 3.5. Exhaust fans are definitely other mechanical means of ventilation. Probably timing the extractor fans in such a way so that there is continuous removal of air and get fresh air through the building. But the energy losses associated with that is significant, as we could imagine. So the idea here is to definitely, I think at this point, and this is what the building code is also recommending, having a fresh air fans that supply air into the house. That way you can make it tighter. I think that answers the question.
Okay, thank you. If not, you're to
Please
the
follow
person,
up. Yeah,
to the person that asked that question. If it didn't quite answer it, sorry, his email's on the screen right there.
Yeah,
So go ahead and
we'll
contact
be happy
him.
to follow up. Yeah.
Okay, great. So Carol, I'm going to ask this question and hopefully I get it right, but if not, again, just check in with Surya. So sorry, could you give some examples of unexpected results from some of the pilots? Just mentioning that it's helpful to see the variation on a few project examples.
That's a great question. In fact, one of the pilots where we were testing one of the measures, spray foam in particular, we had about 15, I think about 10 homes. What happened was this was a kind of a long process because we did the first Energuide audit and then booked a second appointment, get the spray foam contractor in. What happened in between, the homeowners, there were two of them, they decided to do other renovations in the house in that time frame. So this was an opportunity for us. Okay, we are doing this air sealing work, so why not fix other things in the house? And when we did the Energuide audit after, compared the results, we saw there was actually no savings. It was negative savings. So we wondered what could have happened there. And when that was an after fact where we inquired and found out that they actually did some renovations. But why did the savings went down was the question. So we tried to dig into that, and the potential explanations could be like when you're fixing certain places, other places, like fixing certain gaps, other gaps could open up. Like contractors used to call that the whack-a-mole effect. So when you're fixing a gap at some point, other gaps open, which was not noticed. And when blower door test was done and the model was verified, we saw that there was no actual savings. So these are kind of unusual results that we saw in the pilot.
Fantastic. Thank you. So I'm going to ask this question. I'm not sure. It sounds like it's a bit tricky to answer live. So Joad's asking, can you share the distribution of homes assessed based on construction year? Were there recently constructed homes, so like 12 years old, less than 12 years old, that showed significant air leakage issues? And were the homes randomly selected or based on homeowners volunteering to participate in the study?
That's interesting. Perhaps I have a slide that I don't mind sharing here. So here's something I probably could answer this question. So you could see here on the x-axis, we have homes which are from the late 1800 to 2005, 2006. Interesting enough, the opportunity for getting savings from air sealing is from the houses built in the 1990s and later. And this could be various reasons for that. Obviously, somebody who has lived in the house for 30 years and we won't do much of big renovation within that point. We'll wait for the time when the roof starts flying away, then we'll probably then, start doing the roof. And then at the same time, we have some equity on the house and then do other stuff. But that's where the opportunity is there. But the houses which are 30 years or older, they would have done all of those. So these statistics actually show what could have been like the potential is definitely houses which are newer.
I think that's exactly the slide that I was looking for.
I kept it handy. Maybe the question could come.
Yeah, Joe, I'd certainly reach out to Surya if you want that or a copy of the slides. Really hard to verbally describe a distribution. So Ken is wondering, just noting that you were using drones for the industrial buildings and wondering if anyone has used drone studies by flying over residential areas, looking for houses losing the most heat to target that work.
Yeah, actually I've done it myself on our house at some few years back. It's not the technology is available. It is a question of deciding who wants to do it and what sort of data we want to collect. But what I've observed from my own experience was the scan did produce similar results as we saw for the commercial buildings, obviously on a smaller scale. And it did pinpoint areas where you could see where leaks are happening in the house, where there's a lack of insulation, for example, also like in my case, it was showing me that I didn't have enough attic insulation. So this technology that we use actually gave us the U value of the insulation at different areas. So based on the U value, that is how they assess the energy flow through the building envelope. You can quantify the gigajoules equivalent of energy you're losing across the envelope. So once you have the U values, and it makes it even more attractive. And that's why we always recommend, in fact, when we are doing let's say an air sealing program, if you would combine this with a thermal imaging together, you'll get the best solution, because then you'll know where the leaks are happening. And you can start fixing use an 80-20 rule and start fixing the house from where the gaps are bigger. This is the technique of guided air sealing, actually. So you fix the leaks which are more prominent, and then run a blower door test, check the results. If you have achieved, let's say, 80% savings, probably you don't need to go any further. So you can optimize the cost of retrofit in that aspect if you're combining thermal imaging with the blower door test. That would be the ideal way.
Right. Yeah. And I think on the macro level too, this is triggering, I think this is what My Heat does. So there's My Heat is a technology company in Canada that has worked with quite a few municipalities to do thermal imaging of neighborhoods. So they can see in what areas in the communities have the most heat loss based on the thermal imaging. So if you're interested, you can go to My Heat's website and check out some of the work they've done. If I understand the question correctly, anyways, Ken. Okay, so just a couple more questions. So Joseph's wondering about using feedback from the tool for contractors. So he says there are other methods to measure improvement while conducting a blower door. The gauge will directly produce the air changes per hour if the house volume is entered. Is that feedback that's being provided to the contractor right now, or why or why not?
Yeah, it is. It has been definitely, and it's part of the tool itself. We haven't shown it here, but the tool also shows the initial air changes per hour and then the final one. So this is what has been the typical practice of assessing air tightness of buildings. We would look at initial air changes per hour at 50 pascals and then look after what the change is. But the issue before was, okay, we know the air changes per hour, but how does that equate to dollars? How much energy losses have we fixed in that? And that's the reason why this calculator came up, where we would use the change in the air changes per hour at 50 pascals, but then we have to convert 50 pascals to natural infiltration because the house is not always at 50 pascals. A house is probably 7-10 pascals in general. So we have to do a conversion. And that's what the calculator is actually doing. It's kind of converting or normalizing changes per hour at 50 pascals to natural infiltration, which is the normal condition. And that gives you the equivalent energy savings in cubic meter of natural gas or kilowatt hour of electricity or dollar value. And obviously you get to see the change in ACH at 50 pascals also.
Okay, thank you. So we just have time for one more question, and I apologize if we didn't get to your question in the question and answers. Again, please reach out to Soria. Maybe I missed this in the presentation, but where do you find this? If you're going to search for the app, where is it? Is it on Summerhill's website? Where do people find this?
Yeah, it's a good question. It's not yet there. What we have done is the first testing. It's a beta version. We're doing some fine tuning on that, but definitely to learn more about the app, feel free to reach out. We are very happy to discuss further. And essentially, there is some customization opportunities out there. It will be customized to the weather data of the region, customized to the types of houses that we have. And also we customize the screen in terms of what you want to see. If you want to see percentage change in air changes per hour, you want to see dollar value, you want to see electricity or natural gas, it can be customized to that extent. We are very happy to discuss further on that. Please do reach out and continue that conversation.
Fantastic. Thank you so much, Soria, for attending today and for that great presentation. This is a really neat tool, and I hope it gets rolled out across many jurisdictions.
Yes,
as always, I am amazed with your depth of knowledge and humbled to have you here. So thank you.
Thank you so much.
And thank you to everybody for joining us today. So we have the discovery sessions. We move them to every 2 weeks. You probably noticed this. So we'll be refreshing our page in a few days here with some of the upcoming topics. I actually don't have a speaker for the next one yet. So if you are interested in becoming an ally of Efficiency Canada and presenting on discovery, then I would be happy to chat with you. Reach out to me. If you have any questions, reach out to Soria. Thank you, everybody, and have a wonderful weekend. Happy Friday.
Thank you very much. Thank you, Alison. Thank you, Efficiency Canada. Really appreciate it.
Take care.
Take care.
Bye-bye.
Bye-bye. Have a good weekend, everyone.